A couple lessons ago, we learned how to graph exponential functions. Today, we'll be graphing log or logarithmic functions. It's related to exponential in regards to, let's take a look here, since exponential and logarithmic functions are inverses of each other. So, for example, we saw y equals a to the x power, that is exponential. Today we're going to be seeing y equals log base a x. These two are inverses of each other. Inverses. Okay? Inverses of each other. So what that means is if they're inverses, these graphs are able to be reflected about the line y equals x. Remember that line we talked about, the diagonal line? Whatever happening on one side will get reflected onto the other. So what we're going to do today is take the equations that they give us, write it in exponential form, create the table of points for that, and then once we have all these tables of numbers, we can switch the x and the y, and those are the log function graphs. All right, so we're going to find our x and y, and then we're going to switch the order and graph those, because we don't know how to graph logs right away. So we're going to graph the exponentials, flip the points, and those are log points. So the actual steps, and I'll leave these here and you can pause the video and take a look at them, but we're going to change x and y, isolate that log term, change it to exponential form, so that's the important part. Okay, we're going to take the base, use it as a base for both sides, solve for y, and then finally once we create the table of coordinates, we're going to reverse everything. So reverse the x and the y, and that'll give us the log graph that we're going to create. So our first example here, so y equals log base 2 of x, and they're going to tell us to graph this. Okay, so it's a log. We really don't know how to graph it just yet. So the y is isolated, all this stuff, so some of the early steps are already done for us. What we want to do first is write this as an exponential. Okay, so it's in log form, we want to write in an exponential form. So the way we do that, all right, so this is really just going to be written as y equals 2 to the x power. Okay, so that's written as exponential form. And this is something we know how to graph already. And guess what? We're going to use those same numbers as before, create our xy table. So -3, -2, 0, 2, and 3, and we're going to plug all those numbers in and get values. So if we plug in -3, so that's 2 to the -3rd. And remember, negative exponent means you flip the fraction, so this stuff goes to the bottom, so it's actually going to be a 1 over 2 to the 3rd, or a 1 over 8. And I think we've used this example before. 2 to the -2 becomes a 1/4. 2 to the 0, anything to the 0 power is 1. 2 squared is 4, and 2 to the 3rd is 8. Okay, so if we were trying to graph this one right here, and I'll highlight it, if we're trying to graph this, this is the table that would give it. Okay, that's the exponential form. But we want to graph the log. And we already stated that the log and exponential form are inverses of each other. And if they're inverses, we have this x column, we have this y column. So after all that, my log points are going to be that same table, but just everything flip-flopped. So now I have new x's and new y's. So if you want to rewrite the table, everything's going to flip now. So my new points are 1/8 and -3, 1/4, -2, and then it's just going to follow. Everything's going to be flipped. The x's and y's are flipped around. Okay, so these are my new points. These are the log points. So these are the ones that we're going to graph now. Okay, these are the ones we're going to graph. Okay, so I'll go ahead and create a coordinate plane here, and I'm actually going to grab these points and bring them down so we can see them next to the table. Sorry, next to the graph here. Okay, that's the best I'm going to get. Okay, so let's go 1, 2, 3 in these. Oh, no. Actually, I'm going to go 1, 2, 3 in the y direction. Erase, please. Oh, well. There we go, got it. All right, so 1, 2, 3 down, 1, 2, 3 up, and then eventually I need to go 8 outwards. 1, 2, 3, 4, 5, 6, 7, 8. You can see that's my biggest x value there. Okay, so graphing all these points. Let's get some colors here. All right, so my first point is 1/8 by -3. So 1/8 out and -3 down. My next one is 1/4 and -2. 1, 0. 4. 1, 2, 3, 4 up and 2, or 4 over and 2 up, and 8 over 3 up. And you see it's very similar to what we did before, but now it's kind of laying on its side. So we've got this here, like this, and let's analyze that domain and range. Okay, so you'll notice as this graph gets closer and closer to the x-axis, it's not going to cross it, it's not going to touch it, so we've got ourselves an asymptote there. That number is getting smaller and smaller, getting closer there. So this is a vertical asymptote at x equals 0. And I can write that better. We have a vertical asymptote at x equals 0. So what that tells me for my domain and range, so let's see, domain, remember that side to side, it's not going all the way to the left, it will continue to the right, but 0 stopping it on the left, but it's going off to positive infinity on the right. Range, though, is anything stopping it from going up and down? No. So it does continue off to negative infinity and then up towards positive infinity. All right. So the only thing to make note of there is that is the 0 is the vertical asymptote. All right. So let's see a trickier example here. We want to go ahead and graph the following. Y equals 3 log x minus 1. All right. So this is our problem here. Usually we want a number on the base for the log. If there is no base number there, remember it is a 10. So if there's no number there, it's a 10. If other numbers show up, those numbers are the base. But if it's missing, it's a 10. All right, so what we're trying to do now is get that log term kind of isolated by itself. All right, we're trying to get the log base isolated by itself. So we're going to move that 3 first. It's connected by multiplication, so we're going to divide it to the other side. And actually, I'm getting ahead of myself. If we look back at the steps, actually, we're supposed to switch x and y first. Remember, we're doing inverse. So this is x equals 3 log base 10, and now y minus 1. I'm sorry, switch your x and your y first. Now we're going to go ahead and divide by 3 because what we're trying to do is get this y by itself. So take it back to our inverse days. We want to isolate y. So 3 is going to move first, so we're going to divide both sides by 3. All right, so I've got x over 3 equals log base 10, y minus 1. All right. So step 3 is change to exponential form. Okay, because we got this log term now. We can't break the y out just yet. So what we're going to do is take the base, use it as the base for both sides. Okay, so my base number is 10. Base number is 10. So I'm going to use that on both sides. So I'm going to write 10 base. Now this x over 3 is going to become the exponent. So x over 3 is your exponent equals, and I'm going to lift the whole other side to log base 10 y minus 1. So what I did is made a base 10 on both sides. Okay, this base 10 and this base 10. Because what I do to one side, I have to do the other. We haven't changed the value of the equation. We've just changed the way that it looks. Because what this does right now, a base 10 and a log base 10 are actually going to cancel each other out. So the only thing left here is a y minus 1. And on the right hand side, we have 10 to the x over 3. And we actually have something that looks a little bit more doable. We can now get this y by itself. Last step would be add 1 to both sides. So in the end, those 1's cancel. So we get y equals 10 to the x over 3 plus 1. And now this is something that we can graph. We can create the table. So let's create the xy table. Remember, what we're making right now is the exponential table. Eventually we're going to have to flip everything, reverse everything, and create the log table. Okay, so I'll just put that ahead of us. Eventually we need to flip everything, create the log table. So let's plug in the same numbers, -3, -2, 0, 2, and 3. And we're plugging all of those into this equation here. So we're getting 10 to the -3 over 3 plus 1. You can do all this stuff on your calculator. So that's really 10 to the -1 power plus 1, and I'll go through this kind of quickly. That's a 1.1. Next number would be 10 to the -2 over 3 plus 1. Remember, that whole thing's your exponent. So 10 to the -2/3 power plus 1, that comes out to a 1.2. 10 to the 0 over 3, whole thing plus 1. Because remember, you're keeping this part separate and then adding 1 to it. So anything to the 0 power is 1, and then 1 plus 1 is 2. 10 to the 2 over 3 plus 1, 5.6. 10 to the 3 over 3 plus 1. So 3 over 3 is 1, so 10 to the 1 power is 10, and 10 plus 1 gives me 11. Now remember, that's your exponential table, but we want the log table, so we inverse everything. So we flip all the x and y's. So now the y's are this -2, -3, -2, 0, 2, and 3. And now the values that we solved for will be over here. Okay. And now these are the points that we're going to use to graph our log equation. Okay. Let me see if I can pull those down so we can have them on the same screen. Alright, so it's moving. And there we go. Okay, so these are the points we want to graph. We want to go from -3 to +3 on the y-axis. Okay, and then I need to go basically up to 11. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. So that's 11 there. Alright, so 3, -3. Alright, let's graph all these points. So my first point, 1.1 by -3, 1.1, -3. 1.2, -2, so barely a little bit farther. 2, 0. 5.6, so 1, 2, 3, 4, 5, and a little bit bigger than half. And that goes up 2. 1, 2, 3, 4, 5, and a half, and up 2. And then 11 by 3. And so we're getting that same general shape as before. It's that log shape. Right. Now this time, we've got to be careful here. because we do want to look at the domain and the range. Okay, so I'm going to write that down. I want to find the domain. I want to find the range. Now the range is pretty easy. It's going to keep going up, it's going to keep going down. That range never really changes on log values, so it's negative infinity to positive infinity. But this time, the domain, nothing's stopping it from going to the right, so that's positive infinity over there. But this time, it's not getting close to 0, it's actually getting close to 1. All right, and let's see why that's happening. This time, the vertical asymptote is at x equals 1 and not at 0. Because if we look back at the equation up here, this right here, remember, that -1, that is a asymptote shift. And so we can either look at it here or we can look at it on the equation that we created down here. That's a shift. So see, it has a +1 shift, so it's been shifted over. That's why it's not at 0, because last time it was a +0, this time it's a +1. So actually our domain is everything from 1 on to infinity. All right.